So with operations with radical expressions, we had two different rules on day one. Our first rule was the product rule. Remember, the product simply means multiply. And we learned that we could break it up into multiple parts. And then we talked about division. And for division, we determined that we could take it from 1 to 2 or vice versa and go from 2 to 1. So there are times where it is helpful to break a problem apart, and there are times where it is helpful to bring it back together. So down here, looking at each of these examples, we have the fourth root of 32. So again, you would want to break 32 into two parts. 32 is really like the fourth root of 16 times the fourth root of 2, because 16 times 2 would get me 32, but the fourth root of 16 is going to get me the number 2. So that number 2 is going to come out in front. The fourth root of 2 is going to stay inside. Similarly, I want to look at A and B and say, okay, what number near 9 divides by 4? So you break that into 8 and 1. 8 divided by 4 is 2. So we're bringing out 2 A's, and an A is staying behind. 20 divides perfectly by 4, so 20 divided by 4 is 5. So we bring out 5 B's, therefore none stay behind. In number 5, you have a square root. A square root is like an imaginary 2. So you're going to take all your powers this time and divide them by 2. 6 divided by 2 is 3. 3 doesn't divide perfectly by 2. So you kind of think of b cubed as b squared and b. So that means that 1 is going to come out and 1 is going to stay behind. 98 is 49 and 2. So similarly, the 7 is going to come out and the 2 is going to stay behind. But we cannot have a square root of 2 in our denominator, so we have to rationalize. So we're going to multiply by square root of 2 on top and bottom. So that is going to give me a cubed b square root 2 times b all over 7. When you have 2 of the same, they become 1. So root 2 times root 2 is really like 2. So 7 times 2 becomes 14. So when you have a square root as a whole problem, what you want to do is break that up into two numbers, one that is a perfect square and one that is not. So 75 breaks up into 25 and 3. The square root of 25 is 5. X to the fourth divides nicely by 2 so we bring out x squared. 7 is odd, so we want to break 7 up into the number 1 less than 7, making it an even. Then you take the even, divide it by 2, and what is left inside are the non-perfects. So that would be the 3 and the y. Before I start to simplify this, I would want to look at the cube root of 40. And I would want to look at my list of perfect cubes and see if 40 divides by a perfect cube. Is there a perfect cube that would go into 40?
Yes.
So 8 goes into 40. So what you would do is take 40 and turn it into the cube root of P5 Q3 over the cube root of 8 and the cube root of 5. Can I have cube roots or square roots in my denominator? No. So the cube root of 8 becomes 2, but that leaves me with the cube root of 5. So if it's a cube root, how many 5s do I need to get the cube root out of my denominator? 2. So we're going to multiply the top and bottom by 2 more cube roots of 5. Cube root 5 times cube root 5 becomes the cube root of 25 on top. If I have 3 q's, the cube root of q cubed becomes q. P to the 5th has 3 p's and then 2 left behind. So you bring out 1 and leave behind a 2. And then 3 cube roots of 5 just become the number 5. So my final answer is QP cube root 25p squared all over 10. On day 2 for that lesson, we looked at adding radicals together as well as multiplying radicals. So we're going to focus on adding and multiplying today as well. So in order to add radicals together, we have 2 rules that must occur. They have to be what we call like radicals. In order to be like radicals, they must have the same index and the same radicand. The index is the power in front of the root. The radicand is what's inside the root. So at the moment, they have like indexes, but different radicands. But 50 and 8 are not simplified. So this becomes 3 square roots of 2 plus 50, which becomes 25 and 2, minus 4 square roots of 8, which would become the square root of 4 and 2, thus giving me perfect squares. So I can simplify those perfect squares so that I get 3 square roots of 2 plus 5 square roots of 2. The square root of 4 becomes 2. So that becomes 2 times 4, which would give me minus 8 square roots of 2. Now all of these are like indexes and radicands. So what we are going to do is add their numbers or subtract their numbers out in front. 3 plus 5 is 8. 8 minus 8 is 0. And then in 7, we have a case of FOIL. So we do first, outer, inner. So when I do the outer and the inner, I get like terms because both contain the square root of 7. And then last, when you have the square root of 7 times the square root of 7, that is simply going to become 7. So then 21 and 8 are like terms. And I get 29 plus 14 square roots of 7. So for tonight, you are going to focus on adding, subtracting, multiplying. So if you had addition or subtraction, the only way we can simplify those is to have the same number under the square root. So before we can add or subtract, we have to simplify. So 300 is really like 103. 27 is like 9 and 3. And 75 we just did. It's like 25 and 3. That will make all of these like radicals because they will all be left with a square root of 3 because 100, 9, and 25 are all perfect squares. So you'd have 10 square roots of 3 minus 3 square roots of 3 minus 5 square roots of 3. So 10 minus 3 is 7. 7 minus 5 leaves me with 2 square roots of 3. And then in the last problem, you have to FOIL. So you have first, 4 times 2 is 8. 2 times 20 is 40. Outer, so no square root on the 5, so you multiply the real numbers together and you leave the square root. Inner, negative times a positive gives a negative, and 5 times 20 creates 100. Last. And then before you finish, you would need to simplify or break these down if they can. So 40 becomes 4 and 10. 4 becomes 2. 8 times 2 gives 16 square roots of 10. 20 square roots of 2 stays the same. 100 is a perfect square, so it becomes 10. 6 times 10 is negative 60. 15 square roots of 5. Okay, for homework, it starts simple. You're just going to simplify numbers and variables again. When you get into the fractions, you need to make sure for the fractions you rationalize, meaning there are no radicals in the denominator. And then make sure if there are 2 terms, you FOIL. And then make sure you show all of your steps and work. The back of the page is blank. You can definitely use that to put your work on it. You cannot smush it in these lines.